are functions that would look like this. When you have it in descending powers, you could have, we could call it some coefficient k sub 1 x to the n plus k sub 2 x to the n minus 1 plus dot dot dot. So like with some actual numbers in there, like 2 times x to the third plus 3x squared. And polynomials are things where the variable has a power on it. Some criteria are that the variable cannot have a negative exponent. So this is not a polynomial because 1 over x is the same thing as x to the negative first. Okay, so you cannot have negative exponents in a polynomial. Can't be any funny business either. Okay, can't have no, go away. You can't have square root or something because polynomials have integer powers. Okay, so x to the 1/2 is not a polynomial. And just keep in mind that x to the 1/2 power is the same thing as the square root of x. So can't have fractional exponents for polynomials. And so what that means for the graph is that the graph we call is smooth. Okay, it means it doesn't have any corners like this. Okay, it doesn't all of a sudden just jump. It would, if it's changing direction, the graph would do it in kind of a nice curve fashion like that. So the graph has no corners. Let's see what else we can see. No asymptotes, okay? Because polynomials, they can get kind of wavy depending on how many exponents you have in there. Okay, but at some point the polynomial goes off to infinity as x goes to infinity. So there's no asymptotes, okay? You don't almost approach some number but never reach it. So like this is not a polynomial because x levels off, right? It has an asymptote. It never quite reaches whatever this y value is. We said that it has to go off to positive infinity or negative infinity. Oops, so don't check that. This is not a polynomial. This is like a graph of some sort of rational function. It's got an asymptote. It never reaches, it doesn't go off to positive or negative infinity as x goes to negative infinity or positive infinity, okay? This one has a corner, so that's not a polynomial. We said a polynomial is smooth, so those are the only two polynomials I see, okay? Because look, these two, as x goes to negative infinity, y goes to negative infinity. This one, as x goes to negative infinity, y goes to positive infinity. The y values keep getting higher and higher. Okay, let's see what else we can do here. If the end behavior is rising on the left and falling on the right, so end behavior means like as x goes to negative or positive infinity. So rising on the left means the graph will look something like this. As you go to negative infinity on the x-axis, y keeps going up and up and up. And it's falling on the right, so it could look like this. Or there could be several other curves, or it could actually probably just be linear. Huh? This would be falling on the right. So what must be true about the function? The degree is even, and the leading coefficient is positive. So it's dealing with the degree of the polynomial, which is the highest power, and then the sign of the leading coefficient. Okay. So let's see here. Honestly, I don't remember exactly even and lead in odd or even. Yeah, sorry, odd or even, and I don't remember positive or negative for the coefficient. What exactly those do, but I can find it out through a little bit of investigation. Okay, so let's say we've got the function f of x equals. Let's start with positive and even. So you can have here you could have 2x to the third, 1x squared plus 1x plus 1. So if we graph this, 3x to the fourth plus 2x to the third, oops, plus x squared plus x plus 1. We can see that we've got, as we go to negative infinity, y is positive, y is increasing. As we go to positive infinity on the x-axis, look, y keeps getting bigger and bigger to match it, okay? So it looks, so with an even degree and a positive leading coefficient, goes to infinity on both sides, which doesn't match our case, right? But if we make the degree be negative, if we make the leading coefficient be negative, it just, it flips it about the x-axis. Instead of going to positive infinity on both sides, it's decreasing on both sides. So that's not what we're looking for. We want it to be increasing from the left and decreasing from the right. So that does the trick. It makes it at least be alternates. If you change it to an odd degree, so that meaning the highest power is odd. Let me just get rid of one of these terms. So if we use an odd degree, and then if we change that leading coefficient to be negative, then look what happens as we go to the x-axis, as we go to negative infinity on the x-axis. That's that graph that we just sketched here, right? And you could check out a few other ones. I got a lot going on. Okay, so if we check out to the 5th power, to the 7th power, it doesn't matter how high the power is. If it's odd degree, and if it's a negative exponent, it meets the criteria that they're talking about. So the degree has to be odd, and leading coefficient we said had to be negative. So that tool Desmos is a good one to play around with if you're unsure about these graphs. Okay, as x approaches negative infinity, for which of the following functions does fx approach positive infinity? So you can test this. You can get a rough idea of positive and negative infinity by plugging in some numbers that are big. Okay, it doesn't, plugging in a big number doesn't mean you're plugging in infinity. Okay, it means you're trying to approximate, what that should look like. So in other words, we're supposed to say as x approaches negative infinity, which means x is getting smaller and smaller. So we could test negative 100 and see what happens, okay, with these functions. That would be something that's starting to approach negative infinity. Which of the following functions does fx approach positive infinity? So the question is, if you plug in negative 100, which one gives you a really big positive number, going off to positive infinity? And if you plug in negative 100 here, now an odd degree exponent is going to give you still a negative number out, right? A negative times a negative is a positive, times another another negative is a negative, times another negative is a positive, and times one more negative gives you a negative. So this won't go to positive infinity. This will go to negative infinity. But if you plug it in here, negative 100 to the 4th power, that gives you a really big positive number. So positive number times 9, still positive. This one is going to positive infinity as x goes off towards negative infinity. When we plug in negative 100, this is a really big positive number, like they said. Let's check it out here. And actually, it's the highest exponent of the polynomial that's going to dictate the end behavior of the function. So what that means is the highest power tells you what's going to happen with the function. So 8's the highest power. You can pretty much ignore the other powers because as you go off to infinity, they're not going to matter. Okay, they're going to get smaller and smaller in value. So if you plug a negative 100 in for x, it's an even power, so it's going to give you an even number. So that's going off to positive infinity. I think I said an even number. That gives you a really big positive number, right? Negative 100 to the 8th power is a really big positive number. So that's approaching positive infinity. If you plug in negative 100 here for x, that gives you a negative number. But then a negative number times a negative number is going to give you a positive. So this is going to be a really big positive number as well. Now here, if you plug in negative 100, it's an even power. So it's going to give you a really big positive number. But a positive number times a negative number is going to give you a really big negative number. So that goes off to negative infinity. And then here, negative 100 to the 7th power gives you a really, really huge digits for negative numbers. But a negative times a negative gives you a positive, so that goes off to positive infinity. Which is a polynomial. Oh, so we haven't done this. I think I showed it at the beginning of the video, the general structure of a polynomial. Could have those powers, x to the 7th, x to the 6th, x to the 5th. You can't have x in the superscript position. Okay, x, the variable cannot be an exponent. So not this, not this, not this. That's another polynomial.